graph points on polar graphs, which kind of look like the spider webs there for you. You got 5 to 17 odds to do today, and then tomorrow we're doing 6 to 18 evens. Some people in the other two classes have done 5 to 18, all of them, and already turned them in, and I gave them back to them already. And this is 10-7 today. This is the last section Thursday. We're having a test on 6-5, 6-6, and 10-7. A lot of people have not turned in their 6-6 stuff yet. And I'm giving you a practice, actually 2 practice tests tomorrow, which I've taken the test and I've changed numbers from the test onto the practice test. So if you know how to do every problem on the practice test, you should kick this test out. I mean, just knock it out of the park. If you don't know how to do something, you're going to have to ask questions on Wednesday, because Thursday I want you to spend time doing the test. Okay, so get all your questions answered on the test Wednesday, and then next Thursday we got the 4th quarter test, which will replace your worst test of the semester. Okay? Now, I have never done that before. I'm doing that because of coronavirus, because it's been so stinking weird, and it should help some of you tremendously. And I think we're going to have 4th quarter practice test too next week. We're doing a review for it. All right, so I took one of your spider webs. These are called polar coordinates, polar graph, and these are all in polar form. Now, all of your second values here are in what form? When you got pi, what's that called? What measurement is that in? Radians. That's radians. So you can use degrees if you want to change them. So I'm going to have a little review of what we've done before. So first of all, polar form has an r and a theta as an ordered pair. R is the radius, which tells you which circle to put your dot on over here. Theta is going to be the angle that you're going to put the dot on. Now, if you count all these little spoke marks going all the way around, there are 24 of those. How many degrees is it around a circle? So if I take 360 divided by 24, each spoke mark is 15 degrees. And we always start 0 on the positive x-axis. So that would be 0. This is 15. This is 30. This is 45. This is 60. And all I'm doing is adding 15 every time. And you do that all the way around your circle. And how many times can you go around the circle? Forever. Okay, so don't let some of these weird numbers screw you up, like 3 pi. There's a 3 pi up here, so right there. Number 9 says 3 pi. Just keep going. Now, what I want to remind you of is we had a formula I gave you a long time ago that said degrees are to 180 as radians are to pi. You remember that? To change from degrees to radians and radians to pi, I gave you that proportion. Now, you're going to use that only on these problems down here that are in decimal form, and we're going to do part of one of these in a little while. The rest of them, what do you know pi is in terms of degrees? How many degrees is pi? 180. So you're supposed to know that pi is 180. Now, I want to do one problem where r is positive. I want to do one problem where r is negative. And then one of the problems, I want your radians to be positive, and one problem to be radians negative. So I want r and theta to both be negative 1. So we're only doing 2 together, and if we need to do more, we're just going to make them up because I got to have you practice these. Okay? So somebody give me a problem you want to see. Pick a number, any number. You're going to do all of them. Hold on. We're going to do number 11 first. So if I look at 11, doing this number 11, my r is negative 2, and my radians are 2 pi over 3. Well, I'm going to take and put 2 times 180 divided by 3, and that's going to give me 120 degrees. So I'm going to keep going to this next tick mark, which is 120. Does anybody have a question so far? Now, we normally go in one direction for positive angles. Positive angles go in one direction around the circle. What's the correct word? Do we go up or do we go down? We go up. What's that called compared to that thing up there on the wall with that little thing ticking going around? Counterclockwise. So if you get confused or you don't remember which way a clock goes, you can look up on my wall and there's a clock, and whatever way that blue hand's ticking, that's clockwise. The opposite direction is counterclockwise. So when we have a negative angle, we have to go clockwise. So this says that my R is -2 in this, and my theta is 120 degrees on this. So here's what you do. You start right here at what's called the origin when we do X and Y, but on this graph, and you don't have to write this down, but you're supposed to know it. You don't have to write it on your picture. This is called the pole on polar graph. That's called the pole, just like the North Pole. So if I could take myself up to the North Pole, and I could get in a drone or a helicopter and fly up and hover above the North Pole and look down on the Earth, that would be where I would be looking down on this thing right here. That's the pole, and I could see the Earth going around here. Like this outside part would be the equator. Okay? So that's kind of what I'm thinking when I'm looking at this. It's kind of like being above a circle and looking straight down at it. Now, yes?
What does that say again? Pi the 11, 2 pi.
It was 2 pi over 3, and I told you that pi is 180, right?
Yeah.
So I put 180 in there where the pi is, and 2 times 180 divided by 3 tells me that 2 pi over 3 is the same as 120.
Okay. Thank you.
Okay? So I changed it to degrees because I think degrees is easier. Now, we're going to graph this. So at the pole, what direction would you go for -2? Which way is -2? Left. Don't we? Isn't that just the way it was on X lines? It's left. So you're going to start here, and since R is -2, we're going to move 2 to the left. We're going to move to there first, and now I need to go 120 degrees from there. Now, am I going to go clockwise from here or counterclockwise? Is this a positive 120 or a negative 120? Positive. There's no negative in front of 2 pi over 3. So I have to go down here. This is positive. So I've got to go counterclockwise. So am I going to go down from here or up? Down. And I need to go 120 degrees. Well, counting tick marks, that's 1, 2, 3, 4, 5, 6, 7, 8. So from here, I got to go down 8 tick marks. 1, 2, 3, 4, 5, 6, 7, 8. And I got to put a dot right there on that tick mark going out this way on the second circle because my R is 2. And then right here by this dot, you got 2 options. You can show me, hey, that's number 11. You put the number 11 by it if you wish to show me that's where number 11 goes. Or you can write the ordered pair, -2 and 2 pi over 3 by the dot. Who's got a question where that came from? Yes.
Are we supposed to like connect the dots or something?
Are you what?
Are we supposed to like connect the dots?
No connecting the dots. Each dot represents each ordered pair. No, yes, you can write the number 11 by it, or you can write the ordered pair. Now, again, you're only going to put up to 2 on one graph. Okay, because I don't want a whole bunch of dots where it's hard for me to find them. All right, so we did one where the R was negative and the angle was positive. So now we're going to do one where R is negative and R is positive and the angle is negative. So I'm going to do number 7, but I'm going to do this one in blue. We're going to do number 7 in blue. Okay, so what do you think we want to find first? The angle. I plug in 180 for pi. So negative 180 divided by 3 is negative 60 degrees. You all okay where that comes from? All right, now, R is positive 4. So from the pole, where do I go? I go right. 1, 2, 3, 4. I get out to the 4th circle because R is 4. I want a radius of 4. So I go to the 4th circle. And now I'm going -60, so do I go up or down for negative angles? Down, clockwise. Now, do you see if I go up to 60, it's 1, 2, 3, 4. So I gotta go down to the 4th tick mark. 1, 2, 3, 4. I'll put a dot right there, and I'm gonna put the number 7 right there. That's the answer to number 7. Who's got a question? So first, you take R in whatever direction it says from the origin or from the pole, and then if the Y or the theta is positive, you go counterclockwise from there. If the theta is negative, you go counterclockwise from there to get your point. Who's got a question? Yes,
How'd you know to go forward
I
down?
can't hear.
How'd you know to go forward down?
Okay, I look at my clock. As I look at my clock, when I get out there to number 3, when you look at a clock, you got 12 up here, you got 6 down there, you got 3 over here, and you got 9 over here, and this is out at the 3. Which way does the second hand tick? Doesn't the second hand go this way?
Yeah.
Okay, negative says that we go clockwise. So because clockwise is this way, when I got out here, I had to go down because my angle was a negative angle. So I had to go clockwise from there. On my first one, I went here. And I went the opposite direction because clockwise goes like this, right? But on my first one, my angle was positive. So I had to go counterclockwise to get to there. You understand the difference?
Yeah, I get that. I meant like just how'd you know it's forward, like to go down? I get.
Okay, how did I know 4? Because that says it's on the 4th circle. This one says it's on the 2nd circle. Those are my radii. Radii tells you how far to go out to a circle. Okay, now I'm going to talk about kind of 2 different things at once right here. Actually, I guess I'm going to lie. I'm going to do 3 problems. I want to do this one because 2 reasons. One is you got a radical number, and the other one is you got a decimal radian degree. Or not, I said radian degree, that's impossible. You got a decimal radian measure. So you got a radical R and a radian in decimal form. Okay? So what I need to do is, first of all, figure out what does radical 2 round to. So I take my calculator and I hit the square root of 2 and I get some number like that. Just do it right on your calculator. Square root 2 and you're going to get 1.414 something. I believe that's right, isn't it? Okay? Now, I want to find how many degrees 2.36 is. 2.36 radians. What can I use that I've already given you to find out how many degrees 2.36 is approximately? Yeah, right up here. This formula I gave you right here is what I'm going to use. That formula. So I'm going to say D is to 180 as pi, as 2.36. 2.36 is to pi. Okay, so then I'm going to multiply my 180 over to the other side. So D is going to be 2.36 times 180 divided by pi, and you're going to round that answer. Will someone tell me what that answer is to the nearest degree, please? No. Do not DMS. So just leave it, round it to the nearest degree. What is it? 135 degrees. Now, 135 degrees is right here, okay? Which is 3 pi over 4. If you take 3 pi over 4 on your calculator, it's going to be that number, 2.36 something. Okay, that's 3 pi over 4 rounded to 100, or yeah, hundreds place. Okay, so we're going to graph this one now. I'm going to get these things out here out of the way. Get the word pole out of there and leave my 2 answers in there. Put 11 by that. 7 is right here, this is 7. Okay, so where am I gonna go first on this? 135 degrees. So I'm gonna go to the right. Now, am I gonna be on a circle?
No.
I'm gonna be almost halfway between what and what? First and second. 1.4 is a little less than halfway. So I'm gonna go out 1 and not quite halfway, right in there somewhere. Now, is my angle positive or negative? So do I go up or down? Do I go clockwise or counterclockwise? Counter. So I'm gonna go around all the way over to this 135. And I'm gonna be a little less than halfway out past the 1. I'm gonna put a dot right there. And this problem I just did is number 15. How many think your thumbs up on this? Okay, so we are gonna spend the rest of this period doing these homework problems. If you've got any old makeup stuff to turn in, I'll tell you right now. And I'm gonna get it back to you. Some of you still have to make up your law of sines and law of cosines test. I would like you to do that ASAP. And you've got the rest of the period to finish this homework, okay?